Hello everybody! Today we're going to be running a lab activity, the Density of Unknown Solids lab. Today will be just part one of the lab. So in our lab today we are going to practice with finding the density for irregularly shaped objects. So you can see in the picture right here we have 6 different objects. 3 of them are irregular shaped, 1, 2, 3 cylinders. 3 of them are regularly shaped, 1, 2, and 3 not cylinders. So today we're going to be working solely with these 3 cylinders. And you're going to be determining the density for these unknowns, and then trying to use that density to help figure out if any of these 6 objects are going to be made of the same material. So today we're really focusing on finding the density for those 3 irregularly shaped objects, the cylinders, and then determining what they are based on their density. So here we go. Part 1 of your procedure is going to be to record the mass for each of these cylinders, these irregularly shaped solids. And so you can see that they've been placed on a nice electronic balance. So here you can record the mass of cylinder 1. Here is the mass of cylinder 2. And here is the mass of cylinder 3. So at this point, what you would want to do is take a quick pause, go back to your Density of Unknown Solids lab document, and type your masses in here. So the mass for the first object, if you were typing them in, was found to be 29.92 grams. Now you don't have to write grams because it already exists up here. So we just put the numbers in. The mass for number 2 was 30.21. And then the mass for number 3 was 30.03. I think you're getting the point here. As you're following along with this video, you should be filling in this entire data table for part 1. Again, we're only going to be doing part 1 today. Okay. Once you get your data typed in, let's highlight this whole data set and just go up here to the center justification, center alignment, and click that, and now it is nice and neat, and every other cell should be just like that. Okay, back to the actual lab. Once you've recorded the mass for each, we're going to work on using water displacement in order to figure out the volume for each of these irregular solids, each of these cylinders. So for cylinder 1, I'm going to show you some pictures. I want you to read the graduated cylinder with just the water in it and record that volume. Then I want you to read the graduated cylinder with the water and cylinder 1 and record that volume. Once you have those 2 volumes recorded, you need to subtract those 2 numbers so that you can calculate the volume of the cylinder alone. Once you've done that, for cylinder 1, you're going to repeat these exact same steps for cylinder 2 and cylinder 3. So here we are. Here are the 2 pictures we need for recording the volume of cylinder 1. You can see here, right here where the meniscus, this bottom part of the liquid shape, is touching right on the 5. Okay, so this is going to be 5.0 milliliters. So you would come right back to this document here and you would type in 5.0, and again you don't need to type in milliliters because it already exists in the heading above. Then you're going to look at the second picture. Now this is a 10 milliliter graduated cylinder, so each little line in between the whole numbers are equal to 0.2 milliliters. So we can see that this water line is above the 7, so it would be 7.2, 7.4, 7.6 milliliters for this second volume. And we go back here and we're going to type that in, 7.6 milliliters. Now when calculating your volume, you want to take the larger number, the volume of the water and object, and then subtract away the volume of water alone. So if I were to subtract 7.6 minus 5.0, I end up with a volume of the object itself of 2.6. Now, I'm going to show you the pictures for the other two cylinders and have you fill in the chart by yourself. So here you are. The very first picture is the empty graduated cylinder. You should record that volume. And then here again is the second cylinder that has been dropped into the graduated cylinder, and the water volume goes up to here. So here is 7, and we're 2 more above that. And remember, each of the small dashes in this graduated cylinder read 0.2. Record those volumes now, and then do the subtraction to calculate the volume of the cylinder alone. Feel free to pause the video at any point so you can do your calculations. Now for cylinder 3, I had to use a larger graduated cylinder because it was much taller than the other cylinders. So in this case, this is my 50 milliliter graduated cylinder. So if this is a solid number of 30, and then it goes up here to 40, each one of these little lines are 1 milliliter. Okay, so this line right here is 30. So how many above 30 does this water line go? Record that volume. And then we added this really large cylinder into the graduated cylinder, and it rose from 30 all the way up here. Okay, in case you can't tell, this is the 40 line. So how many single lines above 40 am I? Record that volume. And do your calculations to now calculate the volume for our 3 cylinders. Pause the video as needed. Now once we have our mass and our volume for each of these irregularly shaped solids, we can calculate the density for each solid by taking the mass in grams and dividing by the volume in milliliters. Do those calculations now. Mass should be the first number that goes into the calculator, then the divided sign, and then the volume of the object alone. Once you have those densities, it should be relatively easy for you to identify the type of metal for each of those 3 cylinders. Last class, you were assigned work that had you do research on some common metals and their density. You should be able to pull this document up and compare your calculated density to the density of the common metals in that list. When you get to this final column, you're going to tell me what type of metal you believe each of the 3 cylinders to be made of. Once you have completed part 1, you are done with this activity for today. Next class, we'll be going through part 2, where you'll be finding the mass, volume, and density for the 3 regularly shaped objects that were shown in the very beginning of this lab. Good luck. If you have questions, please contact me.